As we typically did with discrete variables, we now need to look at how to find the mean, mode, and median for continuous random variables. We will also look into variance also. The definitions are still the same, and the formulas are still the same, but how would it look like when we're using integral notation? This is what we're going to learn today. So the mode in continuous random variables, obviously from the definition, mode is the value with the highest probability. So what does that look like? It's on the graph, it would be your maximum, the value that occurs at the maximum. So remember, you're always looking at the x values here. So which x value has the highest probability? So which x value has the maximum y output from the graph. For the median, we're looking at the middle number, meaning we're looking at when is the probability, when am I exactly at the half point of my graph. So if I'm looking at, for example, this type of graph, and remember you're finding the area below the curve. So when is the area exactly 0.5? So when is the area here 0.5 and the area here is 0.5? When does that happen? At which x point will that happen? Obviously, this is symmetrical, so you're thinking the center. But what if your graph is weirder in shape? So what we're looking at is from, let's say this is your starting point A up to which x value is going to give me an area 0.5, or x up to which maximum b value is going to give me an area of 0.5. So you can see the notation here, negative infinity to m being equal to 0.5, or m to positive infinity giving me 0.5. So we want the result of the area to be 0.5, and we need to find, this is what you need to find, the x value. For the mean, it's the expected value, and we know expected value, the formula was you multiply x with the probability of it being equal to x and adding that up. And that is exactly what we will do with the integrals also. So remember, f of x is your probability function, and what we're going to do is we're just going to add another x in there that will multiply with our function, and then we'll find the integral. Another small, tiny thing about integrals is that integral is the addition of small spaces below the curve. So that's why we can consider it as a summation here. So I'll go into detail exactly, step by step, with screenshots on how to find the area, how to find the mode, median, and mean for using continuous random variables. So we will rely on this function here, 3 over 4 x squared minus 1. This is defined from 1 to 2. This is our probability density function, and it's defined 0 otherwise. Now, if I'm looking for the mode, so I'm looking for the highest value, you will graph the function itself, so the original function, and you will see when does the maximum occur. So, and then adjust your window based on the domain given. So don't make sure that you always adjust it, because you cannot graph 0 otherwise in the calculator. So you need to make sure that you're just graphing it for 1 to 2. So adjust your window for 1 to 2, and then try and find the maximum value. Now, if the maximum is a bit more obvious, something like this, you will see, oh, okay, the maximum, you can find it on the calculator, it's going to give you 3. So the maximum, the mode of this function would be 3. For the example that we have, it just constantly goes up and it stops here. So for this specific example, it's just the highest value it's the upper bound of the domain. So the mode is just equal to 2. So 2 is the mode of this function. Now, what do I mean by if your function is piecewise? So if it's made up of several functions, such as this one, for instance, how do you graph them? Just have a look at different videos that explain how to graph piecewise, but if you want to just really quickly, you will go to math, and then all the way down you'll see piecewise, and then pick how many pieces you have, so 2 for example, and then you will graph your function, in here, and then you will put the conditions. So for example, x minus 2 from, and you will say, for instance, if you want to do the inequality, so for instance, from 1, you need to go to test. So you'll press second, test, and you will say, for instance, x less than 2. And then let's say the other function is 2x, and I'm going to define it from 2 to 3. Okay, and then I can graph my function. Sorry, I just need to. So this would be the function. I'll change the window since I'm dealing from, my values are from 1 to 3. The probability, it's not actually a probability density function. I've just plotted a random function. But just to show you that you can do piecewise functions in graphing piecewise functions. So this is the mode. So you need to find the maximum of your function itself. What about the median? So as we explained, you want to know when is the area below the curve equal to 0.5. Well, this time you will not graph the function. You will graph the integral of the function. You will graph it from the lower bound, so from 1 up to an unknown x. You'll type in x as it's seen here. You will type in this x, and you will type it all in exactly where it shows. I know it's repetitively shown. So what this is going to do, the calculator is going to substitute different values of x, and it's going to compute the area for each of those values of x. And you're trying to see which x value will give you an area equal to 0.5. So you will graph those, and then you will find the intersection between them. Adjust the window. You can make the y-scale as small as 0 to 1, so make it quite small. And this tells you that when x is 1.73, when I take the integral of 1 up to 1.73, the area below the curve will be 0.5, which means the median is 1.73. You graph these integrals exactly how you type the integrals normally. So you go to math, you take the integral here, option number 9, and then you type it in. So in the upper bound, you'll put an x, and then you'll plot all your values in here. Now, again, if it's piecewise, ideally what you would do is, for instance, you will figure out what's the area from -2 to 0. If the area of -2 to 0 is more than 0.5, it means that your median is within this range. So you will test it out first and see where does the 0.5 lie. So if it's between -1 to 0, then you'll set up one integral to be up to here, and you will only use the first function and see, this is in y1, and then in y2 you'll try and see when is it equal to 0.5. However, if you know that -2 to 0 is something less than 0.5, for example 0.3, then you know that the area, so if we're at -2 to 1/3, and then we have 0. If this area is 0.3, you know that you have 0.2 left in this integral to get you to the midpoint. So you can ignore the first integral and take into consideration the second integral only and say, okay, now that I've covered 0.3, I need the 0 up to x to be equal to, and you will type in your function. So this is in y1, and then you'd want this to be equal to 0.2. So that's how you deal with it if it's piecewise. So it's not something completely impossible to do. You just have to think about it, break down the integrals. So that's for the median. For the mean, using the same formula for expected value, as we said, Remember, the expected value takes x and multiplies it with the probability. So I am literally taking my function and I'm multiplying it with x here in the beginning, and I'm evaluating from 1 to 2. So there's no graphing involved here. You just evaluate it normally, and it'll give you 1.6875. This is your piecewise function. This is your mean. If your function is piecewise, you need to multiply every piecewise with x. So you'll do it several times multiplying by x. The x has to multiply inside the integral, not outside the integral. So it has to be on the inside here. And you don't need to simplify, just type in an x at the beginning and then multiplied by your whole function. Then how do you do variance and standard deviation? Well, similar to what we've done before, you looking at the formula for variance, it's e to the x squared when it's ex being squared. So ex is the mean, so I know how to find that. But how do I find e to the x squared? The same way you found ex, you will now not multiply by x, you will multiply by x squared. So instead of me just multiplying by x, it's now x squared. I'm not asking you to square every x value. I'm asking you to multiply your PDF by an x squared directly here and evaluate the integral. So that will give you 2.9. And then using the formula, I know that I need to take the x squared minus the mean squared. So I will take x squared, take away the mean being squared. So you can see the values here, and that will give me 0.0523. If I want the standard deviation, I just take the square root of that, and it will give me the standard deviation as 0.229. So how to find variance, mean, mode, median, recap through them. They're quite easy. It's just a calculator doing the work, but you just need to make sure that you memorize the steps, because it's just different processes for each one. Let's practice finding them. We go back to this example. This was explained in the previous lesson, so have a read through it. It first starts off with you needing to find the value of C, and we found that by knowing that the area below the curve has to be equal to 1, and then we found the value of C. So now if I want to find the mean of my function, I now know that C is equal to 3/64. So what I have to do is I have to compute 0 to 4, and then I need to multiply x with the with the function itself. So 3/64x. There's another x here, but remember this x is part of finding the mean, and then my normal function squared dx. So I go in my calculator. And I go math integral, and I'm evaluating from 0 to 4. And then I have x is now multiplying with 3/64 x, and then 4 minus x being squared. Just noting all the brackets that I opened. And then we have dx. And that will give me 1.6. So the mean here is 1.6. The mode, I need to graph the original function. Don't accidentally graph it with the x. You need to graph the original function and find the maximum in there. So 3/64 times x, and then 4 minus x squared. I need to adjust my window, so 0 to 4. 0 to 4. And then I can see the maximum is here. The reason I'm not seeing it properly is because my y values are quite big. I'm just going to go at 3 here, and then I'll find the maximum, which happens here. So like you usually do, maximum, left bound, right bound, and I get 1.33. Okay, so just the maximum from graph of 64x 4 minus x squared, it will give x as being, remember, you're not looking at the y value, you're looking at the x value. When does the maximum occur? At 1.33. Okay. And then the median, you will graph the function itself. Notice how I took out 3 over 64 because you're allowed to do that, it's a constant. And then 0 up to a certain x, and I want to see when is that area equal to 0.5. Adjusting the window, I get that the median occurs when x is equal to 1.54. All right, try it out with this question. This question is asking for the expected value and the variance, but first you need to find the a value. So I would encourage you to pause and try this out on your own before you see my solutions. All right, so to find the a value, remember a is just a constant. A over x is the same thing as a multiplied by 1 over x, and I can take a out from my integral. So I know if I integrate from 1 to 4 of a over x dx, it should be equal to 1, because that's the definition of PDF. The area below the full curve has to be equal to 1. And this is equivalent to taking the a out, and I'm dealing with 1 over x dx equals to 1. Now, if this was at a point where you've studied calculus, you can actually find the exact value of a rather than the decimal value we're going to find. But at this point in the course, we're just going to stick to what we have. So we evaluate the integral from 0 to 4 to, sorry, from 1 to 4 of 1 over x dx, and I get this 1.386. So it tells me that a times 1.386 is equal to 1, which means a is equal to 1 divided by that value. So I'm just going to take the answer to make it more accurate. So 0.721 is the answer. Now that I have a, it says find e of x and the variance of x. So I know e of x is just going to be the integral of 1 to 4 of x multiplied by a over x. I know my a value here, d of x. You'll notice the x cancels out, so you're going to end up taking the integral of a by dx only, which again, if you know calculus, you should be able to know how to do that, but at this point, we're just going to type it in exactly as it should be, 1 to 4 of x times, I'll just take the answer exactly for a, divided by, you can do fraction notation. I'm just going to skip that, and divided by x dx. 2.16 is the expected value. So that's for expected value. Now, in order to find the variance, I need to find the expected value squared. So I'm going to take, just need this as an answer. I'm going to take the same integral, but instead of multiplying with x, I'm now multiplying with x squared. I'm multiplying with x squared, and it's going to give me 5.41, which means the variance is equal to 5.41 minus the square of 2.16, and that will give me 0.727. And if I need the standard deviation, I'll square root that. So that's it for these questions. Have a practice through them. Make sure you understand the difference between all the different processes. This is also a nice full example that also asks you to find the probability for each one. So remember, this is the area below the curves and so on. This would be a nice question where find then a such that x is less than a equal to 1 over 4. So this is the same idea as the median, but instead of me wanting the area to be 0.5, I want the area to be 1 over 4. So the same process in here. And the answers are shown. on the next slide, but the answers are done using calculus methods. So only rely on the final answer and compare that with what you're getting.